Alright, so let's have a look at, say you're given like an algebraic equation, and instead of an equals, let me get the right color. So yeah, look, can you see on the left hand side this equation is exactly the same as that, except this one has an equals and this one has an inequality, you know, one of those 4 signs. This one is less than. So, you know, a lot of people get confused, alright, what's the difference in solving these? So the best way for me to show you this is first for me just kind of pretty much run you through an example. So let's first have a look at how you solve this. Now hopefully you're confident that the first thing you do is you times each side by 2. So then you're at 4 minus 2x equals 2. Then the next thing you do is take away 4. So now you're at, you're now at minus 2x equals minus 2. And obviously as well, you could have moved that to this side, and I'll talk about that in a second as well. I'm just showing you how to run through this way. Alright, and the final step you do here as well, yeah, is divide by minus 2. So, and then finally you got to your answer, which is x equals, that equals 1. Don't know why I had like a little bit of a brain fog moment there. But look, do you see how that one's quite straightforward to do? Now listen, solving one of these is exactly the same, except you just need to kind of focus on when you need to flip this sign. And by the way, I'll tell you something. These 2 signs flip between themselves, and these 2 signs flip between themselves. Yeah? It's not like you'll ever go between, if you get an equation with that, yeah, and these pop up, then I don't know what you're doing, alright? So it's literally these 2 flip between each other and these 2 flip between each other. So the only question here is, which you have to worry about, is when do I flip this inequality? And I can promise you that the rest of this is going to work exactly the same. Right, so I've left a space here because we're going to decide what goes there. Then we're here. And finally we get to here. And literally it's as simple as this. Make sure you're clear what's happening at what you're doing to each side at each stage. And the only time you need to flip is if you look here, so read what I've written here, the method of solving inequality. You treat it exactly the same as a normal equation, except you switch the inequality when, firstly, either that you're multiplying or dividing by a negative number. That's the only time you've got to flip. Otherwise, this works exactly the same. So now look, so in this question, we start off with a less than. Now look, the first thing we did to go from here to here was we multiplied by 2. So look, the only time we flip is if we're multiplying or dividing. So here we are multiplying, but look, it's not by a negative number. It's only when both of those are met, when you multiply or divide by a negative number, that you flip it. So we started with this, don't flip it yet. Or if loads of questions, by the way, you won't even flip it at all. You literally solve it just like that. So here's the next thing. Here we subtracted by minus 4. So as soon as you subtract, because that's not multiplying or dividing, you can forget about this one. Already you're not kind of flipping the sign. And it doesn't matter that I'm subtracting by a negative number. I could only if I'm multiplying or dividing by a negative number do I flip. So now listen, this one, can you see here I'm dividing by minus 2. So this is, so firstly I'm dividing, and yeah, minus 2 is a negative number. So this is the time which I flip. That's it. That's literally it. For the sake of it as well, I know some of you at this stage would have added 2x to each side. Let me show you what would happen if you did that. So, let me rock this up. You can do it that way, and you can treat your... shouldn't have rocked that last bit. You can definitely do it this way as well, but you just need to understand what's happening. So just for the sake, I'll rock that out. So, right, so say here you added 2x. So you've got, now you got 4 equals 2x plus 2. And then you would take away 2 from each side. Then now you've got 2 equals 2x. Now you divide each side by 2. And finally you get 1 equals x. Well, this is, so let's, again here, you've just got to be careful about this. So let me kind of write all of this stuff down. Remember, all we've got to kind of decide is, do we flip the sign or not flip the sign? Right, so here, obviously I multiplied by a positive number. So no, it stays the same. Here, I added, so I don't even care what I added by. It's only if you multiply and divide by a negative number. Here, subtracted, don't care if it's a negative number or not. And then finally, we divided, but by a positive number again. So again, I don't need to flip. So look, if I do it this way, I get to this, 1 is less than x. Now remember, before we got to x is greater than 1. So listen, this works exactly, remember, this is exactly the same as that, if you can do that mirror thing. Yeah, so it's exactly the same. But obviously with this one you've got to be careful, because you always got to give your answers x, sign, number. So you've got to do it in that order. So let's kind of also now just explain what that means. So we've now found out that, let's show you what we found out. So now I'm just going to give you a quick understanding of why that makes sense with the actual equation itself. So this one we found that x equals 1, but this one we found that x is greater than 1. So look, because this is an equal sign, by the way, this kind of equation, if you want to think about it, is an equality equation. And the reason these are called inequalities is they're not equal signs. You know how like inefficient is the opposite of efficient. Inequality is the opposite of equality. So anyway, by the way, so the reason x equals 1 solves this is because if we literally plug that in, we get 2 times 1, which you can hopefully are happy with, is just 2 over 2. Yeah, that would literally give you 2 over 2, which is 1. So that's why this solves this one. So now, what this one is saying is that, oh, by the way, it's the answer to this question is every x which is greater than 1. Not 1, because this isn't a greater than or equals to anything bigger than 1, but not 1. And let's have a look at this. So let's try out x equals 2. Because x equals 2 is bigger than 1, so apparently this should work for that. Let's see if that makes sense. So, plug it in, you get 4 minus 4 over 2. So that gives you 0. Yeah? Now the question is, so literally you would get, this would become 0 less than 1. Now read that. This is saying 0 is less than 1. Yeah, it is. So that's why this makes it work. And we'll just pick pick an even bigger number. So we did x equals 10. So that would give you 4 minus 20, 2 times 10 is 20, over 2. That would give you minus 16 over 8, 2, which gives you minus 8. So what it makes this whole side equal to minus 8. Now, this is going to read as minus 8 is less than 1. And it is, because minus 8 is less than 1. So that's why this is correct. Now, let's just, for the sake of it as well, show you why. So for example, x equals 0 shouldn't work. Yeah, because this is saying every number greater than 1 should work. So let's put that in. You get 4 minus 0 over 2, which will just give you 4 over 2, which is 2. So that will make this whole thing, sorry, by the way, come out to 2 is less than 1. 2 is less than 1. Which it isn't. So that's wrong. Now the last one I want to show you is why x equals 1 doesn't work. So if we plug that in, we get 4 minus 2 over 2. So that would give us 2 over 2, 1. So that would make this whole equation 1 less than 1. Now, read that. This is saying 1 is less than 1. Well, 1 isn't less than 1. 1 is equal to 1. So that's why it doesn't work for this. But can you see, if this is, it was say greater or equal to 1, it was like that, then it would have been, because then that would have been x is less than or equal to 1, which it is, it's equal to 1. So hopefully that makes sense. And now and that's really it, right? That literally is it. So the difference between an inequality has loads of answers, whereas an equality just has one, and that's all it is. So sometimes, well, maybe I shouldn't have rubbed that out just yet. Sometimes in a question they'll kind of, so you solve this. Do we say greater than 1? Or do we do less than 1, don't we? And find the answer is greater than 1. Then sometimes they tell you, show your answer on a number line. So if you watch that first video, it would literally be this. So greater than 1. So everything above 1, it works. And remember, draw your line all the way across. Also, but not 1. So don't color that line in. It's not, by the way, good enough just to show that. They want you to clearly show that, look, that 1 isn't included, but everything is. Common mistakes sometimes people do. They'll do this correctly, and then they'll just draw this line. Well, make sure you draw it all the way off the scale, because you're trying to show that, look, everything above. Because this scale ends here, but obviously in real life it doesn't end. So you drawing the arrow all the way across is showing that. You drawing this kind of says, oh, not 1, but up to about 3. So that's no good. So you want to do the whole thing. So alright, so now let's let me show you. So now let's kind of go through a few examples and how it works. So yeah, also what I just kind of showed you at the end as well, how you can test if your answer is correct. I'll talk about that in a second as well. So okay, so let's have a look at this question. It's 3x plus 8 is less than 29. So let's think about this. We're going to just imagine we're solving like if this was an equals. The first thing I'd do is take away 8. Yeah, that would get me to, where is this? 3x. Now listen, over here, because I've subtracted, I'm definitely not going to switch the sign. So just treat it like that, The next thing you do is you divide by 3. So I've divided by a positive number, so don't bother flipping the sign. There you go, x less than 7. So can you see, if I had done something like this, it literally would have been exactly the same. A lot of these inequality questions, you won't even have the sign flipping. So that's kind of nice. Well, not really, because this is easy anyway. They're always going to give you a mark if you have to flip it. So let's have a look at another one. 5x plus 3 greater than 10. So this one obviously start off by taking away 3. Now that's not multiplying or dividing, so don't flip the sign. Yeah, so you go there. Now obviously divide by 5. Let's say you're dividing by a positive number, so again you don't flip the sign. And there you go, there's your answer. Simple as that. Yeah, so these aren't hard, basically. Let's have a look at this. Let me actually get this quote. Give me a second, I'll go find the paper which this came up. By the way, what I'm showing you here are all real past papers, past paper questions. This is on the calculator. Whoops. I'm dropping my stuff here. Give me a second, because I've got like a, I think this one's quite an interesting question. Yeah, found it. Alright, so 3-part question here. So the first question, first part of the question says, you know what, let me snip this. Let me snip this and actually show you what it is. Alright, and I think I'm back. Let me just double check I'm back. I'm back. Alright, so this one, simple enough, hopefully. Make the brush size a little bit smaller. Alright, so this one, look, here's the first thing I'm going to do. I'm going to treat this exactly the same, so I'm going to take away 3 from each side. So take away 3, so I've got 2x, let me change the color as well. So I've got 2x plus 3 greater or equal to 1. So start off by taking away 3. Now that's not multiplying or dividing by a negative number. So keep it the same. Greater than or equal to minus 2. Finally, divide by 2. So that's dividing by a positive number. So still don't switch. There you go. I got my answer. X is greater than or equal to minus 1. So that gets me my 2 marks. That's it. It's nice and straightforward, right? So here it goes. Write down the inequality shown by the following diagram. So let's think about this. So it's not actually related to this. So this thing is working the other way. So I've shown you how to make a, what's it called? If we get to this, you could plot this on the graph. Let's actually do a practice on that, actually. So it's saying this one, if we want to plot this, would be, so it's saying greater than or equal to minus 1. So we would color this in, yeah, because minus 1 is interesting, and greater than. So that's how we do this one. But that's not even the question they're telling us. So it's saying this one, this diagram, what's this one for? Well, let's have a look at this. So you notice there's a 2 here. Firstly, can you see we're going less than? So it's going to be x less than 2. Now, the last thing here is, yeah, be careful. Because it's not colored in, it means it's not including 2. So to write this would be wrong. You've got to make sure you don't include that thing. So you can see it's everything less than 2, but yeah, it's not actually including 2, so don't put that extra line. So this is how you get that one. And this was actually interesting. Write down all the integers that satisfy both inequalities in part A and B. So actually, what I was showing you here was actually useful. So if we kind of do this one now, so this one, we would actually like color it in here. And this one would go all the way. So that's actually a good thing I showed you. So then it's saying, look, write down all the integers which satisfy both inequalities. So it's like which kind of like, which values of x would work for this one and this one. And we only bother about whole numbers. So you can see, like, you know, we can kind of work up the whole numbers in a way. You can see that this one, yeah, ticks this one, but it's not even on this line. So that won't work. Clear, it's for the same reason that won't work. Now this one's interesting. Now this one, you can see it's on this line, yeah, and it is colored here. So this one is one of the ones we want. This one is here and here, so that's good. This one's here and here, so that one. Now be careful with this one. It's here, but remember, it's saying it's not included there. So really, and then finally you can see these ones, they're not even on the bottom line. And we're looking for all the integers that satisfy both inequalities. So your answer should be minus 1, 0, and 1. So that's how you get the marks for that one. Exam style question as well. Alright, so let me, what else have I got here? Alright, so there's another one like that as well. Let me bring that up as well. Alright, back, hopefully. Double check I am back. Alright, so this one. So this one, again, like, don't get scared by this one. This is, you've got to first just treat it exactly the way you do this. First thing you do is just multiply it out. You see? Now, obviously, you haven't done anything. Yeah, it's not like you've done anything to either side, so you might as well start off by doing that. So look, 3x minus 6 is less than or equal to 9. Then look, we're going to add 6 to each side. That's adding anyway, so we're not going to do anything there. So we're going to get 3x less than or equal to 15. Then we divide by 3. And hopefully you kind of see as well, a lot of these questions, they don't even involve the flip. But you've got to be happy with the flip. And it's really just looking at what you're doing to each side. And then, yeah, your answer is just x less than or equal to 5. So there you go. Here we go. The inequality x less than or equal to 3 is shown below. And we can see that, right? So x is less than 3. So all of these numbers are less than 3 on the line. And notice this is colored in, because it's saying less than or equal to. So it is colored in. If they had done this, yeah, just remember that would be for x less than 3. There's a difference when they put that extra line and make it equals to. Alright. So let's draw another inequality on the number line so that the following integers satisfy both inequalities. So these ones, yeah? So basically we're saying that this has to be included, 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 and this has to be included. So there's actually two things you can do. So the first way, hopefully you can see this, is let's make that a big thing here. Alright, and can you see we could then just do the line all the way up. So there you go. Can you see? If I do that, then this, all of those, this, and this are included. The other thing you could have done, if you're feeling a little bit bright, not that it'd get you any extra marks. So when I say bright, I just mean like if you did it, it'd still be right. You know, don't try to be smart here. Is you could have also done this. So you could have put the circle here, but don't color it in. And then do all the way down there. Now that also works, because obviously you can see that this one, this one, this one, this one, this one, this one, just as I said, are included on both of these lines. When we're talking about the blue one and the black one. But this one doesn't actually include -3, so that would work anyway. So either one of those would have done it. So yeah, so the following integers satisfy both inequalities. Yeah, that sounds reasonable. Let me see, there's actually an inequality where they actually ask you to flip the sign. There was one. Okay, so that'll coming up anyway. It's alright, so let's have a look at this one. Oh wait, okay, let me snip that one as well. Alright, looks like I'm back, hopefully. Yeah, okay, so, yeah, I've just kind of dumped it all over this. Don't worry about this line or anything. So look, I don't really care about the first part, you know, but what I am interested about is the way they're giving you this inequality question here. By the way, there was no more further thing, it was just like loads of lines here. So, you know, another thing you've got to get comfy with as well is that even though this is a relatively straightforwardish inequality which you just treat like the rest, they might give it you like in this kind of like little story going on. So this one's talking about like there's a stacking chair here. When a chair is added, increased by height by this and width by this, find the expression, that's fine, who cares? But then it goes, look, a rule for the maximum number of chairs that can be stacked before they fall over is 4n plus 35 less than 70. Sorry, multitasking there again. Let me make the pen thickness a little bit. Oh, that's very thick. Okay, that's better. So yeah, you're told that, look, there's a rule. 4n plus 35 less than 70. That's like the maximum number of chairs which can be stacked. Then it goes, before the whole thing tips over. And it goes, what's the maximum number of chairs that can be stacked? So, you know, let's first solve this, because n is the number of chairs. So the first thing I'm going to do, I'm going to take away 35. So I get to 4n less than 35. Hopefully you're happy. I shouldn't be flipping the sign here, because I'm not multiplying or divided by a negative number. Then finally I divide by 4. Right, now this was on a calculator paper. So if you don't know what that is, but yeah, here's what it's saying. The answer will come out to n is less than 8.75. Now, if you just leave that, by the way, this last bit is a 3-mark question. You'll get 2 marks because you solved the inequality. But this one's actually asking, what's the maximum number of chairs? So what you're saying here is that you found that, look, n, as long as the number of chairs is less than 8.75, this thing won't fall over. That's a maximum. But here's the deal. It's saying what's the maximum number of chairs. So you can't just say 8.75 or 8.74 because technically it's saying less than. Because that's dumb. You can either only have like 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on chairs. So here's the deal. Here's what you have to kind of understand. 9 is too much. If you had 9 chairs, can you see if you do that, you get 9 less than equal to that. Yeah? 9 is less than 8.75. That's rubbish. Okay, so it's not 9. The answer is 8. 8 is the most chairs, which still works for this whole thing. So the answer for this should be 8. And that's how you solve it. And hopefully that makes sense as well. So let's get rid of this. Let's kind of cut off my, what's it called? It's called, cut off my title as well. It's okay. We'll do with, I guess. What are the... Okay, a few more interesting ones. Right, so you got 7y is less than 3y plus 6. So first thing we do is take away 3y. Now that's actually quite interesting, you know, because we don't know if y is a positive or a negative. But because we're taking away, we don't care. So look, this one still stays the same. Then we divide by 4. Again, dividing by positive numbers, so we're not going to change the signs. Which is less than 6 over 4, which is 3 over 2. Yeah, you could also write y equals less than 1.5. So that's how you solve that. So yeah, look, again here as well, if you want to add or minus y's to each side, that's fine as well. Which actually brings me... Oh, maybe... Yeah, nothing. So okay, so what about this one? This is a good question. This one came up in the exam as well. There you go. It wants you to solve n. I think that's it. Let me just double check that that's exactly what they were asking you for. They might have been asking you for like int. Right, so this was the actual question which came up. So as n is an integer, right? So n can only be a whole number. Because list the values of n such that this. Now, this one threw a lot of people off, from what I understand. By the way, just in case you're wondering, this exam came up when I actually took the GCSE. So I don't know if I got it right. Hope so. So look at this. So with this one, you've got to understand this isn't just your normal inequality. This is two inequalities at once. So the first thing, if you don't understand how to do this, is go to my intro. And this one, basically, so when someone writes this, it's actually dealing with two inequalities. So 3n less than 13 and minus 6 less than 3n. So what you do is you solve each of these separately. So with this one, you just divide by 3. Yeah? So that gives you n less than, what would that be, 4.25? Yeah, so that's this one. And this one will give you, again, you also divide by 3. So it'll be minus 2 is less than or equal to n. So that's the same as saying n is greater than or equal to minus 2. Now think of this on a number line. Right, so let's just have a look at this one. N is greater than or equal to minus 2. So this one includes all of these. But yeah, it would just be, if you want to kind of just draw it on a number line, it would look like this. Okay? So for the other one, which I'll do in blue, that's kind of less than 4.25. So it's somewhere down here. Imagine that's 4.25, which obviously doesn't look like, it looks like 4.5. Just imagine it was. Then it goes all the way here. So let's have a look at all of them which are included. This one's included because this one's actually coloured. That one's included, that one's included, that one's included, that one's included, that one's included. And 4 is just included in both as well. You see that? 5 isn't. So that's the answers. Yeah. List the values of n such that. And it's literally minus 2, minus 1, 0, 1, 2, 3, and 4. That's how you get the 3 marks. Yeah, let's give you one more. You'll notice that a lot of questions you don't even flip the sign, which is a little crazy to me, but yeah, alright. Let me okay, so again, just take this step by step and solve it like you would if this was the equal. So the first thing you do is times by 4. So that's multiplying by a positive number, so don't flip anything. So now you have 30 minus 3n is greater than or equal to 3. Now let's take away 30. So now you're at minus, alright, stick with blue. That's greater than or equal to minus 27. And then, what am I talking about? No, I made a mistake again. So, what am I? Because this one should have been 12. Yeah, because we've got to start times both sides by 12, by 4 here. So that's where we are. Then you take away that. So you get to minus 3n. It's greater than or equal to minus 18. Now, we divide by minus 3. So this is where you're going to flip the sign, because you're dividing by a negative number. So finally you get to n, but now you've got to flip the sign, and minus 18 divided by minus 3 is 6. So that's the answer. The answer is n is less than or equal to 6. So that's all the inequality is done. That really is all there is to inequalities. Any much more to say other than that? No, that's inequalities. I've given you a lot of information, but for the most of it, look, if you get an inequality bit of algebra, do it exactly, and I do mean exactly the same way you would for a normal equation, just that you flip the sign whenever you multiply or divide by a negative number. That's it. What's the next thing I'm going to go through video-wise? Trial and improvement. Alright, so that'll be the next video.